Look at any major urban economy after dark. The city's survival depends entirely on millions of invisible, rapid interactions, routing goods, capital, and labor. Yet, when policymakers build an entrepreneurial ecosystem from scratch, they typically reach for macro-level levers. They adjust national interest rates, offer sweeping tax incentives, or negotiate broad trade policies. This approach creates a foundation, but it fails to generate actual innovation. Lowering corporate taxes might save a company money, but a tax bracket cannot design a prototype, write code, or convince an angel investor to fund a new founder. Data shows that applying the exact same top-down policies to two different regions often yields radically different results in startup survival and economic growth. The problem lies in the definition. In many policy circles, ecosystem has been diluted into jargon, meaning a city with a high density of startups, rather than a biological or structural framework. Real ecosystems are highly structured networks of resource exchange. The true engines of economic development exist exclusively at the micro level. To understand why an economy succeeds or fails, we must look past national borders and map the precise network of local actors orchestrating resources. A functional entrepreneurial ecosystem is a multimodal network where specific actors route capital, human talent, and knowledge between one another. An isolated startup is highly vulnerable. Without a direct connection to these flows, the venture quickly collapses from a lack of inbound resources. In network science, power belongs to actor centrality. The most influential nodes are those that bridge the gaps between previously isolated participants. When we map these connections, the actors with the highest centrality are universities, venture capitalists, and digital innovation hubs. These central nodes capture early-stage ventures, provide structured mentorship, and distribute the immense financial risk of early-stage exploration across the network. Tracking these specific micro-level connections provides the only reliable predictor of a region's long-term economic transformation. Successful ecosystems are not engineered from the top down, they are wired from these central nodes outward. A newly formed venture faces immediate resource starvation. Founders need talent, legal expertise, and capital before they can generate their first dollar of revenue. Hub nodes, like university incubators, solve this by clustering scattered resources into a dense geographic footprint. In emerging markets, these hubs serve as localized safe havens. They provide the physical infrastructure and mentorship required to build a functional business. UK data demonstrates this structural clustering, with 784 academic spin-offs tethered to the dense university networks of the Greater Southeast. This clustering follows a triple helix model, braiding together university research, private industry, and government support into a functional hub. This model provides the structural spine for regional tech ecosystems globally, from mature technology parks in Brazil to growing innovation clusters in Southeast Asia. These hubs lower technology transfer friction, allowing academic research to reach the market as commercialized products. Without these physical hubs to anchor the entire network, the triple helix immediately unbraids, and new startups starve in isolation. An inherent mismatch exists when an agile startup integrates its technology into a massive legacy system, like a national healthcare network or heavy manufacturing plant. Bridging this gap requires an ambidextrous intermediary, a specialized actor translating radical innovation into institutional bureaucracy. Inside a hospital or large firm, these intermediaries simultaneously explore new startup technologies while exploiting existing operational knowledge to keep the system running. This overcomes the proximity problem. Physical closeness is irrelevant if the cognitive and organizational distance between a startup and an institution is too vast for them to cooperate. The intermediary reduces this cognitive distance by aligning the startup's product with strict regulatory reality. This managed relationship prevents the startup from burning capital while waiting years for institutional approval. The presence of these intermediaries determines whether a region can actually deploy innovation, or if it merely generates ideas that die in pilot phases. We cannot simply export the Silicon Valley model to developing regions and expect it to function. The drivers of ecosystem growth change based on the local context. In high-income OECD countries, foundational elements like basic education become statistically insignificant. Growth is driven instead by R&D transfers and postgraduate education. In emerging markets, the drivers flip. Formal venture capital nodes are often missing, and government programs become vital lifelines. In these environments, macro-level infrastructure and formal financial institutions are frequently fragmented or inaccessible to street-level ventures. Founders survive through entrepreneurial bricolage, recombining whatever informal resources are immediately at hand to keep their businesses moving. Rural and agricultural entrepreneurs substitute missing formal capital nodes with informal social networks and family support. Physical resource constraints force highly localized supply chain innovations, such as the repurposing of industrial containers to maintain the distribution of palm oil. Attempting to enforce high-income R&D policies in an environment operating on bricolage completely misallocates regional capital. An ecosystem's architecture must match its developmental reality. Missing formal nodes must be bridged by informal networks before advanced technology transfer can occur. Digital transformation provides the underlying infrastructure that physically rewires the architecture of the entire ecosystem. Digital regulatory sandboxes, predictive AI models, and global e-platforms dramatically reduce the friction of finding talent and capital across borders. This enables open innovation, where startups pull in external knowledge while simultaneously commercializing their own internal intellectual property through networked partners. Implementing artificial intelligence acts as an accelerant, simultaneously boosting inbound knowledge acquisition and outbound commercialization of intellectual property. Digital platforms serve as transnational bridges, allowing local entrepreneurs to access high-income resource pools without migrating. This digital substrate upgrades the ecosystem's bandwidth, allowing resources to bypass geographical and institutional bottlenecks. We have analyzed 3 distinct network architectures: the mature triple helix, the digital transnational bridge, and the emerging market bricolage network. But when a sudden, massive systemic shock hits the global economy, it is the underlying network architecture that ultimately determines exactly which businesses survive. Macroeconomic shocks immediately sever standard supply chains, forcing an immediate pivot to emergency resource distribution and local relief efforts. Rigid, poorly connected ecosystems fracture immediately, as isolated startups are cut off from the capital they need to endure. Resilient networks react by rerouting resources. Nodes with high actor centrality utilize open innovation edges and social capital to keep local ventures alive. The health of an ecosystem is determined by the density, speed, and resilience of the micro-level resource flows between its members. Top-down capital injections will simply bleed out if the underlying network lacks central orchestrators and cognitive proximity. You cannot legislate an ecosystem into existence. You must wire it from the nodes up.